All right. Good morning, everyone. Welcome to the first session of Saturday morning here at Webcam. Today, Irina Zaks and I will be presenting matching algorithm implementation using the Drupal framework. Irina and I are both from Fibonacci Web Studio. Irina is our fearless leader, and I am our director of projects. We work on a variety of web apps and websites for higher ed, as well as nonprofits and other institutions. I'm gonna talk the theory of the matching algorithm, and then I will hand it over to Irina to do a more technical demo. Great, and yeah, feel free to ask questions in the chat, and Jean-Francois will be our moderator and helping us make sure we answer those once we have walked through some of these slides. I'm gonna actually, are you?
And before Tori is gonna jump into the slides, I want to remind everyone it's a camp. Please keep it in mind.
Yes, it's a camp. And I do have the captions turned on. I don't know if they're actually helpful for folks, but I'm trying it out. I'm trying out new tools I saw yesterday. All right. So a brief overview of what I'm going to talk about today is we're going to talk about what is matching. Matching is a pretty common and time-consuming task in academia, so we'll talk about some examples. We'll talk about stability, optimality, and other advantages to automating the matching process versus doing it manually. And then we'll talk about the matching algorithm and a module that can be used on any matching project. Irina will go through some of those more technical details and do a demo, and we'll talk about the code and details and then open up for questions and discussion. So what is matching? So students complete applications for various programs or courses that they might be interested in. Students rank those programs or courses to indicate their preferences. And then programs rank students based on their applications. After that, students need to be assigned to programs. This process is called matching. You see here the matching in the news. Match day is a really big deal for medical students who get matched with residencies. And obviously in a time of coronavirus, that's a slightly different process, but it is a very common process in academia outside of just medicine. And we'll talk about some examples of that. So medical schools residency matching, as we just talked about. Law school clinics also do matching. Assigning teaching assistants to classes and sections is an example of matching. You might match patients to clinical trials, summer and spring break trips, matching students to class sections, and matching students with advisors. There's also the freshman seminars here at Stanford, wherein students get matched with different freshman seminars. There's a lot of different examples of matching within academia. And there are challenges associated with matching. First and foremost, more students than there is program capacity. An example of this is that the Supreme Court Clinic at the Stanford Law School has 10 slots and over 100 applicants listed as their first choice. So not everyone will always get into the program of their top choice. Professors also might want to have control over who goes on their trip or who's in their class. For instance, if there's a spring break trip to Brazil, the professor might want to give priority to students who either know Portuguese or are learning Portuguese. The class might need a wait list, or the trip might need a wait list. It's a very time-consuming process if it's done manually. You might get emails from students asking for favors because you're a human that's managing this process, versus if an algorithm is managing the process, that's less likely. It saves time on revisions and reshuffling. And if it's done manually, it's difficult to ensure stability and optimality. So the solution is the stable marriage algorithm. The algorithm ensures that the assignment of students to classes and programs is stable. So for every student, there is no class they prefer to their assigned one that is not already full with students whom the instructor ranks higher. So there is no pair of student or professor that could upend the situation. It's also optimal. For every student, there is no stable matching where they're placed in a class they want more than the assigned one. If optimized for students and if optimized for professors, in any other stable matching, no class could include a student ranked higher. And we'll get into a little bit later how the process can be optimized for either students or professors, but those are the two options for how the stable marriage algorithm can work. The stable marriage algorithm also allows for classes and programs that have waitlists. And it can, as I said, can be optimized for either students or for professors. And now we're going into the demo, which means I'm going to stop sharing my screen and hand it over to the lovely Irina. Assuming that I can figure out how to stop sharing my screen. I see. Stop share. All right, Irina, your turn. You're muted.
And I'm muted. Great.
There you're not anymore.
All right. So Tori mentioned that we have two projects where we were doing matching, and we decided that it is time to move away from custom code and make it the module that can be used easily on more or less any site. I'm going to go over steps that people are going on both sites where we're using this matching algorithm. This is a little bit, for those who are interested in the background, this is the paper, very nice paper, lovely, especially part 6. Thank you for those who read papers from the beginning till the end. This is a very lovely demo. It's like, this is a very lovely demonstration of how things are being matched. And this is like an overview of what people are doing in the process. So first step is there's a list of students. Each student gets to choose what courses they want to select. So they can add to their schedule or remove to their schedule. Important abstractions here for us was that we eliminated linked like very specific course structure, because course structures can be different in different organizations. And sometimes it can be courses and sometimes it can be trips. For example, on the spring break, alternative spring break program at Stanford, students select trips and then they're being ranked. And in the module that we developed, we're going away from standard course structure. So here students can select whatever trips or courses they want to have, and then they can rank those. So this is a demo and this is the camp. So some things of this demo don't work, the others do. So right now, if I decided that I only want to be in math, take only math B and C, I will not be able to rank math A. But if I say, oh, I want to try any course, then I will, then they will see all their courses here. So once they have their courses, this is time when students can do ranking. They can say, oh, I really want to be in math B, and then they're like, oh no, I actually no, I want to do it the other way around. And they can do it as long as as long as they are open, as long as schedule says you can do this until April 15 or until April 24. Once students, oops, did I break something? Yes, I did. Wonderful. Once students finish their ranking, then professors, then what happens next is we have this applications that are created for each student, where you have application for student Collins for the course Math 101. And this is when professors can start ranking students. whether it's professors or administrative office, or it is doesn't matter. And each professor, I'm looking right now at the administrator's screen where I can see everything, and I can see who is doing what, and professors would normally see only their part. And so once applications are ranked, we have this table and structure that can be used by more or less any combination. Like, it can be used for trips, it can be used for courses, it can be used for quarters, it can be used for medical programs. Because what happens, the way we decided to build it, we have a structure called application, and application has name of the course, name of the student, rank by student, and rank by instructor. And this is how we created the structure that is described in the paper that you can read on the front page. And then this is where all the magic lives, because instead of going through the very lengthy process that is usually done manually or with custom programs, we click Run Match, and everyone is matched. We also do color coding, so now you can see that out of 6 students that applied to class 101, this one was accepted into this class. These are people who were accepted in at least one of the classes. And unfortunately, Collins was not accepted to any of the classes because there are only 6 slots and 7 students. And if something changes in this ranking process, like for example, if for some reason professor decides to change ranking or student decides to change ranking, we can do and run the match with new ratings. Okay. Do you guys have any questions? If you don't have any questions, then I'm going to give it back to Tori.
I do have a question, Irina. You're using Drupal here. Could you explain to us a little bit how it works? Is this a module that you install?
Okay, so let's talk about it. So Sean is also going to answer your question. So I am going to share my screen again. And I believe almost everyone is very well familiar with the Drupal. Rachel, how are you doing? Okay, since there is no answer, I'm going to proceed. So I'm going to dive a little bit about specifically Drupal things. So we built the foundation of the module is content type called application. For this demo, we didn't worry too much about how this application content is being built, because there can be lots of different ranks, lots of different rules, how students can rank things or how program can rank. But the module itself is built on this application, and it is contrib module. And this is the contrib module that we can put on any Drupal 7 or backdrop system. I don't think that we have code right now that is completely polished. So if somebody wants to use it for any of their processes, we're happy to kind of explain how we're doing, but it's not something that we can contribute to Drupal.org right now, because it just takes a lot of work to do, to make model that is completely contributable, right? Does it make sense? And the reason why it is in Drupal 7 is because we had our, like ASB was built in 2014 first, or 2015. Tori probably remembers this time from student affairs perspective. Was reasonably troublesome project that we had to take over from someone else. And this is when we had to go in and do the actual matching coding. And then when we did the similar thing for Mills Clinics, this is where we said, okay, we need to, we need to put it in the module. And I would like to announce, unless you people know, that Gale and Shapley got Nobel Prize in economics for this matching algorithm. So we're working with Nobel Prize laureates, which we do kind of on the regular basis. You know, we built, Tori, we have at least 3 websites where we work with Nobel Prize laureates, and we're, you know, a little bit proud of that. Supporting research and academia. So we are, and I want to thank everyone who worked on this, both this presentation and this module behind the scenes. This is a community, and we're very grateful. I'm not getting Nobel because I'm not doing the research. There are a couple of other prizes that I'll apply to. Well, probably Mary Poppins will be my most favorite. Okay, Tori, do you want to talk a little bit more about matching, because I think it might be interesting for people to see where things can be applied and what is the difference between, there's some fine details to this matching process, and I think it would be nice to, even if it's, go ahead, Tori. It's like I'm not good at multitasking.
That's okay. Yeah, I'll go through sort of the finer details here. Sorry, I'm gonna cough into my elbow. So there, as I said before, there are 2 different ways that the algorithm can be optimized. Hopefully my screen sharing is working and actually sharing my presentation. Please yell at me if it's not. So the first is that the algorithm can be optimized for students. And I'll go into the sort of the step-by-step of how this might work. So all students apply to the class of their first choice. The class has a capacity queue, which then places, the class with a capacity queue then places onto its current acceptance list up to queue applicants who rank the highest. So, which means that when sorry, I'm gonna stop talking so fast, which means when there are fewer than queue applicants. So if there are fewer than the capacity, and rejects the rest. Rejected applicants then apply to the class of their second choice, and in each class, current acceptance list is filled up to capacity with the top rated applicants from the new and existing ones, and the rest are rejected. This continues until the process terminates, when each student is either on a current acceptance list in one of the classes or was rejected by all the classes he applied to, if there are more students than the total capacity of classes. Then all current acceptance lists become final acceptance lists, and each class sends the acceptance letters to all students on their final list. There's a different way that this algorithm can be optimized, which is optimized for professors. So in this case, each class offers admission to the first Q students on its preference list, where Q is class capacity. Each student who received offers picks their top offer and conditionally accepts while rejecting all other offers. Each class that has n available spaces due to rejections then offers the admission to the next n students on its preference list. Each student with new offers then picks their top choice from the new offers and possibly a conditionally accepted one and reject the rest. This continues until the process terminates, when each class is either full or gave an offer to every student. Then all conditional acceptances become final acceptances, and each class sends confirmation letters to all students on their final list. That's the distinction here between the algorithm being optimized one way versus the other. And Irina, do you want to talk through the details of the Mills Clinic application portal?
Yeah, I can say a couple of words. This was a last minute presentation. The reason why we included this text here was to give people an idea of what steps people are going through in the Mills Clinic, and then which is different from the next application, which is for student trips. Student trips have, I believe, students preference, and Mills Clinic has, I believe, a clinic's preference. And this is, I want to underline here that this is, and there's some more information in the slide notes, but what I want to underline here is, like, in this application, we're not dealing with how ranking is done. The beauty of this application for me is that we're working with the final ranking. So we don't have to deal with any, like, why did you rank this student over that student, or why students selected you know, certain courses. This is completely excluded. This all happens before we do the matching. So the matching module only deals with the mathematical part of the algorithm. Okay, and for Mills student, we don't have wait list. And with Haas trips, we do have wait list. And then mathematics for that is slightly different. So we have, like, the module has two slightly different algorithms implemented. So if anyone is interested in using it, we are here for you.
Great. Sarina.
Thank you everyone for coming. We really appreciate it.
Thank you, Irina.
Thank you, Rachel. So if anyone has any questions, I'm happy to talk about, you know, matching or whatever any subjects we want to talk about until next session begins. And I wanted to mention, I'm pretty sure that everyone here was in the opening remarks, but we do have lunch hall open in case we want to move our, you know, want to move to general discussion and just chat. And I don't think we mastered art of break rooms, but I'm sure that our video leader, Jean-Francois, there's like not enough things for you to making this camp happen. It's just like really amazing. So I'm just like, thank you very much.
You know what's amazing? The people who do the talks, not the ones who are behind the scenes managing the Zooms.
I would say it doesn't, one doesn't happen without another. So I think that community is the key for us. And I think this is why we stay here and don't move somewhere else.
All right.
Thank you.
Thank you to both of you for this talk. It was really interesting. I'm really looking forward to learn more about this this application, this module. I did hear about it being used at the law school with great success. It's also really very a very sensitive subject when you talk to law schools who apply to very prestigious clerkships, and there is a lot of it can be very, very sensitive for people to, you know, be accepted or not. It can define careers in the long run.
Oh, yeah.
For them. So it's nice to know that there is a strong unbiased algorithm that can help them find the best match possible for all parties.
Yes, we are very, I think that it was a very interesting project, and we're very happy that we were able to support projects that need this algorithm and make sure that it happens actually strictly by following the math rules, not like, oh, I'm sorry, I kind of forgot what was the ranking. I moved somebody around. I'm sorry, it's my fault, but sometimes it's a little like, you know, we understand that you're sorry that you misplaced the ranking, you didn't notice the ranking, but you know, now we have algorithm that works very precisely. So having precise tools usually helps. And I would like to show off a little bit. The data structure that we've selected allowed us to adjust on Thursday mechanism for people to be enrolled in quarters rather than in the full year very efficiently, because we're living in the interesting times when things have to change very quickly. And it was clear that the architecture that we've chosen, with this architecture, we're able to address this issue very efficiently.
Great,
So
great. It's also nice to see how you can rely on a piece of software that is, as I said, unbiased, but also offers transparency, against any accusation of preferred treatment from one student to another. It's just you can because of the credibility of the Harvard study that it relies on, it gives you and your the people who use it, the faculty members, the assurance that it is a product that, a matching that does not suffer any preference treatment.
Yep. Okay, so do we want to all stay in here, or should we go into the hallway?
Can go into the hallway, sure.
Because I don't know, like, what would be more efficient.
Anybody else has questions?
Yeah, I have a question.
Right.
Would this be super relevant to someone who's just a basic PHP user, or is it something that everyone's going to need to know, like the blurb says, or is it more if you're more advanced with PHP? I'm so sorry. I'm probably not asking properly. I guess I was wondering what level someone would need to know Composer as a PHP user. Like, I'm a very, very basic PHP user. So I was just, I'm sorry. I wanted to ask a question. I don't think I asked the right one.
Well, I think you asked the question that triggers discussion, and then I think during this discussion you will figure out more things that you need to know. Can I rephrase your question? Was your question related, like, if you're a basic PHP user, do you need to know a lot about Composer?
That was my question. Thank you so much.
I'm sure that people in this room will have very different perspectives on this. I think it would be a really cool discussion to hear what you guys think about it. Jean-Francois, Sean, Andrea.
Yes.
Well, what I'm noticing is there's another session going on about learning Composer, so I'm wondering if you're in the wrong one. Or did you mean?
That's what happened. I am so sorry. Yeah, so someone's copy hasn't kicked in yet. Thank you for presenting.
To answer your question, we can talk about Composer if you want, but there's a whole Zoom session going on right now talking about
completely
Composer.
Irrelevant and kind of embarrassing.
Sorry.
Thank you guys. No, thank
worries.
you. Sorry about that.
I think what I understood as the question was differently, was from Rachel's question was whether you need expertise in development to install this module. That was kind of how I understood her question.
For the save.
Well, you're saying, Irina, this is a Drupal 7 module that you were talking about. So this doesn't you don't use Composer at all.
No. It's Composer has nothing to do with this session. I got caught being greedy. Succeeded all day yesterday, but today I finally got caught. It's early. But no, the same question would apply to Drupal, basically at what level you would need to worry about algorithm matching. And I see right on the page, it says advanced intermediate. So that answers my question. So there was no need to ask it. Thank you guys for your patience.
Sure, I would love to though have a discussion about whether Drupal users and PHP users need to know Composer.
But that's completely irrelevant to this room.
It's completely irrelevant to this presentation, but it's very relevant for people who are sitting in this room. That's kind of my 2 bits on the topic.
Thank you, Irina. Appreciate it.
This application, do you need any special, imagine an extra tables in the database on Drupal? How does, I'm kind of curious. I have a hard time wrapping my head how this application is working as well. And also, I'm kind of curious, either on the front end, is there any, what kind of JavaScript library is being used, or is it only relying on the Drupal libraries, JavaScript libraries?
There's not even JavaScript. So
Okay.
the application works with a structure that is called application. That's the one that I showed,
Okay.
that has 5 elements. It has to have the student name, course name, student name, ranking by student, ranking by professor. It can be professor or program, doesn't matter.
Okay.
It's like one matching party with another matching party. And
Okay.
then the 5th field is result. So it's either accepted or not accepted or waitlisted.
I got it now.
Right?
I understand. I was not clear. I never used applications in Drupal. And so I did not realize how you can create an application within Drupal to just and use the existing entities in Drupal for this purpose.
We are creating, so content, this is a content type. We're not doing entity. We're just
Okay.
sticking with the most basic Drupal concept. So we're doing
Okay.
content type called application. We create it manually.
Okay.
And then there is the part that we're not showing in this demo that belongs to how you can do ranking in a variety of ways. You can do, so there's a couple of things that we didn't build for this applications, like how people do ranking, how do this drag and drop thing. There are different ways of implementing it. We can reuse out of the box Drupal library that is used. It's not even library, it's a concept with weights that is in Drupal, sitting in Drupal. And we are using combination of flags and flag weight module for simplicity in one application. And in the demo, that's what we're using. But in the real application, we have some custom code that generates this additional drag and drop stuff. You can also allow people to simply enter number, like 1, 2, 3, 4. That is the matter of convenience. And then there's a little bit, the part of the custom part is how we're moving this ranking from the screen where students or professors are doing ranking, how we're moving that into application. That would be built differently every time because this is where there are custom requirements. Some people want to do it by quarter. Some people want to do it for entire year. Some people, so there's lots of different custom things. And the module only deals with the mathematical part that is exactly same for all algorithms that are, so there are a couple of different options. One is like, it's optimized for students or optimized for instructors, and whether there is waitlist or there are no waitlist. So these are parameters that we can address in the module. But how the ranking is done is always built custom for a particular program. Okay.
Okay. Rachel,